Perhaps the most obvious sources of groundwater pollution in limestone areas are trash-filled sinkholes. Sinkholes are often viewed as a nuisance, or in some cases even a liability. As a result, people have a natural tendency to fill them with trash and debris, not understanding the potential to contaminate drinking water supplies. As rainwater mixes with trash and garbage in sinkholes, it is rapidly funneled downward to the water table or into cave streams with essentially no filtration of chemicals and bacteria. Many old country dumps and even some modern landfills have leaked toxic chemicals into our groundwater. Another common source of groundwater contamination is animal waste. Runoff from cattle operations, as well as pig and chicken farms, can easily move downward through open cracks and sinkholes to pollute wells and springs. Pesticides and fertilizers used for agriculture, as well as those applied on golf courses, also have the potential to pollute karst groundwater. Rainwaters mix with the chemicals applied to fields, and the polluted runoff enters sinkholes to contaminate the groundwater. Gas stations store diesel and gasoline in large underground storage tanks. Throughout the nation, underground storage tanks have leaked gas and diesel fuel into the groundwater. In some cases, the fumes have been detected in cave air and home basements. If the petroleum product reaches a spring, it usually turns a distinctive orange color and has an oily sheen. Rains falling on junkyards and into parking lots can also lead to petroleum contamination and, in some cases, even pollution by heavy metals. A more hidden but common cause of groundwater pollution are septic tanks. People living in rural areas dispose of their waste through a buried tank with perforated lines leading off in several directions. Unfortunately, soils are usually thin in limestone areas, so the bacteria-laden water is often inadequately filtered before reaching the water table. Water from septic tank filter lines commonly cause polluted water to mound above the bedrock. The septic water can easily enter a well if the steel casing is not perfectly sealed or if a crack exists in the casing. Nearly all pollution sources have the potential to contaminate limestone groundwater. Trash-filled sinkholes, septic tanks, and animal waste runoff are the most common problems. In some cases, the polluted water can actually be seen entering a cave. But more often, the contamination is diluted to make spring water look clean and pure. The contaminated water is not only a danger to our drinking water supplies, but it has the potential to kill the rare and endangered species that live in caves. These include salamanders, blind fish, colorless crayfish, bats, and isopods. The Environmental Protection Agency and similar state organizations oversee sites that have the potential to contaminate groundwater or facilities that have already caused pollution. At these sites, monitoring wells are installed and samples are routinely taken to ensure the protection of our underground drinking water supplies. In addition to the high risk of groundwater contamination, there are other problems unique to limestone regions. In many karst areas, sinkholes are difficult to identify because they are often very long and shallow. As a result, homes are sometimes built within the sinkholes without knowledge of the potential danger of flooding. Areas that appear to be safe from storms during the dry season can be flooded just after a few inches of rain if the sinkholes drain slowly. Filling sinkholes with debris or trash causes them to drain even more slowly. Sediment runoff from construction sites can enter sinkholes, clog them, and increase the risk of flooding. If you add to this the increased amount of storm runoff from paving and development, sinkholes that once handled drainage from storms now may fill rapidly and endanger property and roadways. There are ways to reduce the risks of sinkhole flooding. Stormwater retention basins can be constructed to hold back rainwater running off parking lots. To help reduce the risks of groundwater contamination, wetlands can be constructed in the basins. Cattails and other wetland plants are able to absorb heavy metals and other chemicals. One method to help sinkholes drain better is to dig them out and replace the soil with large rocks called riprap. Riprap can slow down the velocity of the water entering the sinkholes and help to hold back the soil particles and plant debris that could clog them. Another method of increasing the drainage rate from sinkholes is to drill a shallow well in the sinkhole bottom and construct slotted pipe above it. This type of drainage standpipe does have the potential to increase the risk of groundwater contamination. Therefore, drainage pipes constructed in sinkholes should be lined with a sand filter to reduce the risk of groundwater contamination. Another risk common in karst terrains is sinkhole collapse. A house located near a sinkhole or cave has the potential to slowly sink or even collapse. Cracks in bricks or uneven walkways are telltale signs of slow ground sinking. Diverting stormwater from roofs and roads can often increase the chance of collapse. In some cases, homes are built over soil-filled sinkholes that can suddenly collapse due to slow piping of soil particles downward through cracks to the water table. Diverting storm runoff from highways can lead to sinkhole collapse by the same slow process. Farm ponds and wastewater holding impoundments can also collapse as the result of soil piping through solution-enlarged joints. But there are ways to locate sinkholes and caves before construction takes place. Geophysicists can use techniques like microgravity, electrical resistivity, and ground-penetrating radar to locate voids in the subsurface. The protection of our nation's limestone groundwaters lies within the hands of the people working for the EPA and state agencies such as Superfund, Solid Waste, Water Supply, and Groundwater Protection. Our county and city planners and engineers are working to solve these problems as well. But this is not enough. Even the diligent work of our hydrogeologists and environmental specialists cannot prevent all groundwater contamination. We all hold a responsibility to protect our drinking water. Each and every citizen must practice safe and proper disposal methods of any substance that could taint our groundwater. Through education and public awareness, we will all feel safe to turn on our spigot, take a long, cool drink, and smile, knowing the water is clean and pure.